All right, if you're a piping engineer and you've got an interview coming up for an oil and gas project, you're in the right place. Think of this as your last-minute cram session. We're going to cover the absolute must-knows so you can walk in there feeling confident and, walk out with that job offer. Okay, let's get right into it.
So picture this. You're sitting in the chair, right across from the hiring manager. Things are going great. And then they lean forward and ask you a straight-up technical question like this. And suddenly, your mind just goes blank. Yeah, we're going to make sure that does not happen. By the end of this, the answer to this question and a whole lot more is just going to roll off your tongue.
Okay, first things first. You have to know your fundamentals. And in the world of piping, that foundation is built on two things: picking the right material for the right service and knowing the codes that govern everything. This stuff isn't just trivia, it's the language of the job.
Now look, here are the workhorses of the industry. When an interviewer asks about materials, they're not just listening for a name. They're listening for the why. Saying A106 grade B for high-temp process lines versus just A53 for utilities, that immediately tells them you get the context. Same thing for stainless steel. If you connect SS316 to corrosive environments, especially with high chlorides, it shows you're thinking about the long-term health of the entire system.
Next up, the codes. Look, nobody expects you to have these things memorized word for word, but you absolutely have to know which one is the boss for your project. ASME B31.3 is pretty much the Bible for any process plant. But here's a pro tip. Mentioning a client-specific standard like SAES-L for a Saudi Aramco job, that's a huge power move. It shows you did your homework and you're ready to play by their rule.
Okay, so we've moved from materials on a spec sheet to actual pipes in the field. Now we got to talk about the craft of actually joining them together, welding, and just as critical, the science of proving that that weld is perfect. This is where the theory really hits the dirt.
An interviewer might ask you about welding docs. This is where you need to sound like you've been there. You don't just check the welds. No, you review the welding procedure specification, the WPS. You make sure it's backed up by a procedure qualification record, or PQR. And you confirm the welder has a valid welder performance qualification, the WPQ. Just using those acronyms correctly shows you're a pro who knows the process inside and out.
So how do you prove the weld is good? Well, think of non-destructive testing, or NDT, as your own personal diagnostic toolkit. If an interviewer gives you a scenario like, "We think there's a crack inside a weld," you don't just say, "We'll test it." You say, "I'd call for radiographic testing, RT, to see what's going on inside." If it's a crack you can see on the surface, you specify dye penetrant testing, or PT. Matching the right test to the right problem, that shows you're a sharp, practical problem solver.
All right, now for the moment of truth. The pipes are all welded up, the joints have been inspected. It's time to prove that the entire system can take the pressure. This is all about the Hydrotest and the quality assurance that wraps around the entire process.
Being able to walk through a Hydrotest procedure in an interview shows you're not just a book-smart engineer, you understand how things work in the field. It's a methodical process, right? You clearly define your test limits, you carefully fill and vent it, you gotta get that air out, you bring it up to pressure and you hold it. And that walk down, it's not a casual stroll, it's a meticulous check of every single flange, weld, and joint. This shows you're serious about safety and procedure. And there it is. The answer to that question from the very beginning. According to ASME 31.3, the Hydrotest pressure has to be at a minimum 1.5 times the design pressure. Simple, direct, and it's a non-negotiable fact you just have to know. No hesitation, just the formula.
Quality control isn't just one single event. It's this whole chain of documents, this paper trail that proves integrity every step of the way. It starts with checking the material test certificate for the raw pipe, and it goes all the way to tracing that pipe's unique heat number to a specific weld on a map, and then finally compiling everything into a final test dossier. And hey, if you can talk about managing a punch list, that shows you know how to actually get a project over the finish line.
Okay, you have the knowledge. Now we're going to lock it in. Let's run through a quick rapid-fire Q&A, just like you'd get in a real interview. You ready?
First one, the one we've been waiting for. What is the pressure test formula?
Test pressure equals design pressure times 1.5. Clean, simple, and correct. Next.
All right, question 2. How do you find a weld defect?
You use the right tool for the job. You use PT for surface defects, RT or UT for internal stuff, and MT for flaws in magnetic materials.
Let's try a design question. What's the minimum slope for drain lines?
The typical industry rule of thumb is a slope of 1 to 100. That makes sure everything drains properly.
Back to materials. When do you pick SS316 over your standard carbon steel?
Use it for corrosive surfaces, and you have to be especially careful in any environment that has a high chloride content, which can cause real problems.
Okay, here's a tough one. The Hydrotest passed with flying colors, but later the line starts leaking. What could have happened?
This is where you really show your experience. A leak after a good test could be a bunch of things. Maybe poor root penetration that just didn't fail under static pressure, or misaligned flanges causing gasket problems. Maybe the welder used the wrong electrode, or there was contamination, or even a high stress point that only failed once it was under real operational load. Answering like this shows you can troubleshoot tough problems.
So let's wrap this up. Here's your final checklist before you walk in that room. 1. Have your key formulas memorized, especially that Hydrotest pressure one. 2. Know your codes, especially B31.3. 3. Master your NDT toolkit. Know which test to use and why. And 4. Understand that QA/QC is the whole story of quality, from the raw material all the way to the final sign-off.
And that brings me to my last point. Anyone can memorize an answer off a slide, but a great engineer, the kind of person they want to hire, can explain the why behind the answer. Why is the test pressure 1.5 times the design? Well, it's about the factor of safety. Why do we trace heat numbers? It's about accountability. If you go into that interview ready to explain the why, you're going to stand out from everyone else. Good luck.